1.
Okay, here's part 2 of your formative exam. We're starting off with number 5 in this segment. Number 5 is asking us what gas sample contains a total of 3.0 times 10 to the 23rd molecules. Well, we start off with what we know, just like we always do. 3.0 times 10 to the 23rd molecules of anything times 1 mole of anything is 6.02 times 10 to the 23rd molecules of anything. It's just like saying a dozen. Molecules cancels, and you are left with your number of moles of anything. It then gives you some examples in your choices, which you'll have to figure out one by one. It gives you 71 grams of chlorine, which is a diatomic element. We know that 1 mole of Cl2 is 70.906 grams of Cl2. We know that by looking at the periodic table, getting the molecular mass for chlorine, and then multiplying it by 2. Grams cancels, and we're left with moles of Cl2. If that doesn't match what you got up here, keep going. Then it gives us 2.0 grams of H2. Do the same thing. 1 mole of H2 as your conversion factor, 2.016 grams of H2. That's off the periodic table. Multiply the molecular mass of hydrogen by 2 because it's a diatomic element. That gives us our moles of H2. If that matches, go ahead and stop there. If it doesn't, keep going. 14 grams of N2. That's another diatomic element. 1 mole of N2, we know from the periodic table, is 28.014 grams of N2. Grams cancels. That gives us our moles of N2. And 38 grams of fluorine. That's another diatomic element, so we're multiplying our mass by 2. 1 mole F2 is 37.996 grams of F2. That gives us our moles of F2, and we are looking to see which one matches. Number 6. We are given 9.03 times 10 to the 23rd molecules of H2. We're multiplying that by our conversion factor. We're trying to get to moles of H2. 1 mole of H2 is always equal to 6.02 times 10 to the 23rd molecules of H2. Molecules cancels. We're left with our number of moles of H2. And that's our answer. Number 7. Number 7 is asking for the type of reaction that's shown. Which one of the types of reactions that are shown, which one's going to produce a salt and water. A is saponification. Don't choose that one. That's an organic chemical reaction, and we have not talked about those. B is fermentation. And while we did talk about that being a chemical reaction, we did not talk about it specifically in the reaction that's behind it, so that's not the answer. C, esterification. Also an organic chemical reaction that we have not talked about. Don't pick that. Neutralization. The product of an acid-base neutralization reaction is always a salt or any ionic compound and water. Number 8. This one is asking which equation represents a double replacement reaction. If we look at A, the sodium is replacing the hydrogen in water. That is a single replacement reaction. So that's not what we're looking for. B, we're starting out with one reactant, and our product is two reactants, or two products. That is always a decomposition reaction. So that's not what we're looking for either. C is lithium hydroxide plus hydrochloric acid yields lithium chloride plus water. That is our double replacement reaction. It's a special type of double replacement reaction called an acid-base neutralization reaction, but it is a double replacement. And finally, D is a hydrocarbon and oxygen, giving us carbon dioxide and water, which is always a combustion reaction. So that's not our answer either.